Hello guys, so for this video lesson, we'll actually be talking about the fundamental counting principle, and specifically for this video lesson, our focus would be on defining the fundamental counting principle, its illustration, and some applications by showing an example. So let's now proceed on our proper discussion. So let's start with the definition of fundamental counting principle. So this definition is taken from the Book of Lighthold College Algebra, and it says there that if one event can occur in m different ways, and if after it has happened in one of these ways, a second event can occur in n different ways, then both events can occur in the order stated in m times n different ways. So this concept is quite abstract, I understand. So medyo dili pagid kay nato siya gakasabtan. And I think mas ma-appreciate nato ni siya if we go deeper by having an example. So I have here an example. A store has 3 different drawing pens in 2 different colors. The question is, how many available pens does the store has? So kung naa kay tulo ka different drawing pens, and then kada drawing pens naa siya 2 different colors, so pila man ang available nga pen ana nga store nga pwede pilian. Okay, so let's have now our solution, or let me show you on how we can answer this. Going back to the example that was presented, so in this particular example, the situation is kung mupalit ka og drawing pen na ay duha ka butang nga dapat i-consider. Unsa nga klase nga drawing pen and unsa ang color ana nga drawing pen. In this problem, there are 2 events for a particular variant of drawing pen. Now, first, we will have to make an illustration. Since this is an introductory discussion about fundamental counting principle, so I guess it's good if we will show an illustration to give you more or to help you nga mas masabtan ang concept behind FCP. So in here, I'll be using a tree diagram in a table. So the first event, we will consider the first event as the selection of drawing pens. And we know that there are 3 different drawing pens. And let's just say, since it's not being mentioned in the problem, let's just say that one of the drawing pen is a marker. And I'll symbol that as letter M, big letter M. And then for pencil, big letter P. And ball pen, big letter B. Okay? So these are the 3 kinds of drawing pens that we will be considering in this particular problem. Now, the second event will be the different kinds of colors, and there are 2 different colors mentioned in the problem. So in here, let's say that this is red and blue. Again, it's not being mentioned in the problem, so we can just assign any color that we want as long as these are 2 different colors. So we have red, and I'll have a symbol of small letter R for that, so that I will not be repeating writing this again, okay? And then blue, and we will have our small letter P as our symbol for that one. And of course, for each kind of drawing pen, the 2 different colors would be red, blue. Okay, so that's why you have here red, blue for pencil and red, blue also for ball pen. Now, this would mean that if you will have to connect this, okay, so marker, you can choose a marker which is the color is red. So let's have a symbol of that as MR. So that's one of the available drawing pen with a particular color. And this would also mean that if you have a marker, you can also choose a blue color. And so you have MB for that as the symbol. And this happens like that with all this, with all those 2 remaining different drawing pens. Okay. So as you can see here, we are able to illustrate on how we could show how many available pens does the store has. So there are how many? We have 1, 2, 3, 4, 5, and 6. There are 6 available pens. In short, for this particular condition that is being mentioned in the problem, there are 6 ways or 6 available pens, no? Or 6 ways that you can come up with a kind of pen in which the two things that you have to consider is the what kind of drawing pen is that and what color is that one. Now, applying the fundamental counting principle, okay? So we know that if there are two events that occur at the same time, we can multiply them. And we have here first event multiplied by the second event. Again, we have two events here. So that would mean in the first event, we have three ways or three different ways of choosing, no? Because it's mentioned that there are three different drawing pens. So that would mean in the first event, there are three ways of choosing. And on the second event, which actually represents the two different colors, we have two ways of choosing what kind of color is that particular drawing pen. And so 3 times 2, that would be 6, which is actually the same answer when we did the illustration. So therefore, going back to answering our problem, therefore there are 6 available different drawing pens in 2 different colors. Alright, so we have here another problem, but this second problem is a little bit different with the first example that we have presented. This one is a problem that is without repetition, but still using the fundamental counting principle. Now, according to the problem, to determine how many positive integers of two different digits can be formed from the integers 1, 2, 3, and 4, we apply the fundamental counting principle. So, basically, we can see that we have to choose two different digits. So, since we are choosing two different digits, there are two events that will happen. The first event is to choose the first digit, and then the second event is to choose the second digit. But then, for this particular problem, in doing or in choosing the first and the second digit, it has to be given consideration that the two digits are different from each other. And then these two digits, ang imong kuhaan ani is kanirang 1, 2, 3, and 4. So, but pasabot ani, kung ang first digit nimo 1, dili pwede nga ang second digit 1 gihapon. Because again, ang ingon niya, two different digits. So, we will have to show the solution of this. Again, first we will illustrate using a tree diagram, and then we will apply the fundamental counting principle. So again, there are two events for two different digits. So the first one is to choose the first digit, and then the second one is to choose the second digit. And then of course, we have to take consideration that the two digits are not the same. They have to be different. Now, in here, we can say that the first event is the tens digit. Okay, the first digit. Okay, so if since in choosing the first digit or in choosing the tens digit, since it is the first event, there would be four possible ways that you can choose. It's either it is 1, 2, 3, or 4. Now, if 1 is being chosen, the possible numbers for the second digit, which is the ones digit, would only be 2, 3, and 4. Because again, there is a particular condition that we have to achieve. It has to be different digits, two different digits. So if 1 is chosen, the second digit has only how many? Alright, there are only 3 possible choices if 1 is already chosen. So 1 is not anymore included in the second event because 1 has already been chosen in the first event. Now, if in the first event 2 is chosen, that means on the second event it is not anymore included. It would only be 1, 3, and 4. Okay? Now, if 3 is being chosen on the first event, that would also mean that on the second event, 3 is not anymore included to avoid that there would be duplicity or to avoid that they have the same digit. And then the same with the 4. If the 4 is being chosen on the first event, then on the second event, 4 will not be included. So as you can see here, in the first event, there are 4 choices, no? Either you choose 1, 2, 3, and 4. But when you have already chosen any of these four numbers, no, under for tens digit, kung nakapili na kag isa aning upat, ang mahitabo maapektuhan ang imong second event, no? Nakabase siya sa unsa imong gipili sa first event man. So, ang mahitabo, whatever number is being chosen, basically if you look at our second event, whatever number is being chosen, the second event would only have 3 choices. Kung 1 ang mapili, tulo na lang ang imong pilion. Kung 2 ang mapili, tulo ra gihapon ang imong pilion. Kung 3 ang mapili, tulo ra gihapon ang available nga choices. Okay? And kung 4 ang mapili, tulo ra gihapon because of the condition that these 2 digits should be different. Now, that means, of course, if I will just have to continue, doing now the tree diagram, that would mean that these are the possible numbers. Okay? Right. So that's it, no? And there are 12 ways. So the possible numbers would be 12, 13, 14, 21, 23, 24, 31, 32, 34, 41, 42, and 43. And if you can see here, these are all 2-digit numbers that are different from each other. Walay nagkapariha din ha, no? Walay 11, walay 22, walay 33, and walay 44. So there are 12 ways. Now, that's the illustration using a tree diagram. Now, if we apply the fundamental counting principle and multiply, okay, again, there are 2 events. The first event is the selection of the tens digit, and the second event is the selection of the ones digit. And again, by the illustration, we know that in the first event, you have 4 choices, but after choosing 1 to any of the 4 choices, on the second event, there will only be 3 choices left. And so, it will now be 4 times 3, and that would be 12. Therefore, we can say that there are 12 ways that it can be arranged into different digits. Alright, so we're done with the lesson about fundamental counting principle, and I'll see you again on our next video lesson. Have a nice day, everybody.